Hello. The Center for National Distance Learning and Open Schooling, CENDLOS, has made it possible for us to have another session of our SHS2 mathematics program. I'm Betty. This is our fourth lesson on indices and logs, and our topic for today is rules of logs and their applications. By the end of today's lesson, you should be able to state the rules of logarithms, use the rules to evaluate logarithmic expressions, apply these rules to solve log problems. In our previous lesson, we learned about how to relate indices to logs in a given base. We changed equations from index form to log form and vice versa. In today's lesson, we shall consider the rules of logs and how to apply these rules to solve log problems. Let's go. Let's first refresh our minds on indices and log relations. Now, consider the log equation that says log base 10 of x is equal to a. Now, this implies that x will be equal to 10 raised to the power a. We are going to call this equation 1. Again, we want to look at log base 10 of y is equal to b. And this also means that y is equal to 10 raised to the power b. We are going to call that equation 2. Now, we want to look at the first rule we use in logs. Now, if log to the base 10 of x is equal to a, like we said before, it means that x is equal to 10 raised to the power a. Again, if log base 10 of y is equal to b, this implies that y is equal to 10 raised to the power b. Now, we are going to call these equations 1 and 2. Let us multiply equation 1 by equation 2. What that gives us is xy is equal to 10 raised to the power a times 10 raised to the power b. Now, we are going to use indices to simplify that statement. Then we will have xy to be equal to 10 raised to the power a plus b. And we are going to call that equation 3. Now, we want to write that equation in log form. I'm sure you haven't forgotten what we did in our last lesson. So writing that in log form, we are going to have log to the base 10 of xy to be equal to a plus b. Now, from the very beginning, if you can remember, we said a was equal to log base 10 of x, and b is equal to log base 10 of y. So we'll substitute these for a and b. That gives us log base 10 of xy to be equal to log base 10 of x plus log base 10 of y. That is the first rule for logarithm. And the first rule, as we saw, says that log base 10 of x times y will be equal to log base 10 of x plus log base 10 of y. The rule can be seen in a reversed form. In other words, we can also say that log base 10 of x plus log base 10 of y is equal to log base 10 of x times y. What we are saying is that the logarithm of the product of two numbers is equal to the sum of their logs. Or we are saying that the sum of the logarithms of two numbers to the same base is equal to the log of their product. We can look at some examples. If we have log base 10 of 13 plus log base 10 of 2. This will be equal to log base 10 of 13 times 2. And I'm sure you will notice that the 13 times 2 is in brackets. So this will be equal to log base 10 of 26. Again, if we have log base 10 of 9 plus log base 10 of 11, this will be equal to log base 10 of 9 times 11, which is log base 10 of 99. Or if we say log base 10 of 7a plus log base 10 of 5b, this will be equal to log base 10 of 7a times 5b. So it will be equal to log base 10 of 35ab. Considering our first equations, where we had log base 10 of x is equal to a, and we said that implied that x is equal to 10 raised to the power a, we can call that equation 1. Once again, log base 10 of y is equal to b, which implies that y equals 10 raised to the power b can be called equation 2. Now, let's divide one equation by the second. So that will give us x divided by y is equal to 10 to the power a divided by 10 to the exponent b. And again, if we use indices to work the right-hand side, we will get x divided by y to be equal to 10 raised to the power a minus b. I'm sure you remember that rule from indices. Now, equation 3 can be written in log form. And that becomes the log base 10 of x divided by y is equal to a minus b. But I'm sure you remember that from the beginning, we said a is equal to log base 10 of x and b is equal to log base 10 of y. So we can substitute. Then we get log base 10 of x divided by y to be equal to log base 10 of x minus log base 10 of y. Now that is the second rule for logs. So the second rule we are going to be using says that log base 10 of x divided by y is equal to log base 10 of x minus log base 10 of y. Again, this rule can be reversed. So we can say log base 10 of x minus log base 10 of y is equal to log base 10 of x divided by y. Or we can say it the other way. Remember that for each of these laws, you can use it from the right-hand side to the left-hand side, or from the left-hand side to the right-hand side. For example, log base 10 of 30 minus log base 10 of 2 is equal to log base 10 of 30 divided by 2, which is log base 10 of 15. Again, log base 10 of 35x minus log base 10 of 7 is equal to log base 10 of 35x divided by 7, which is log base 10 of 5x. Again, we can say log base 10 of 5a minus log base 10 of 20b is equal to log base 10 of 5a divided by 20b. And that gives us log base 10 of a over 4b. Again, we are going to start with log base 10 of x is equal to a. That means that x is equal to 10 raised to the power a. We want to raise both sides of this equation to an exponent n. And when we do that, we are going to get x raised to the power n is equal to 10 to the power a all raised to the power n. Then that gives us x raised to the power n to be equal to 10 raised to the power n a, or n times a. Remember, it's one of the rules we used in indices. We can write that in log form. Then it becomes log base 10 of x raised to the power n is equal to n times a. So we have log base 10 of x raised to the power n is equal to n times log base 10 of x. I'm sure you remember that from the beginning we said a was equal to log base 10 of x. So all we have done there is to substitute that expression for a. So that is our third rule for logs. And it says log base 10 of x raised to an index n is equal to n times the log base 10 of x. So the power comes down to multiply the log of the number. This rule can be seen in the reversed form. And the reverse will say n times the log base 10 of x is equal to log base 10 of x raised to the power n. The exponent of a logarithm becomes the coefficient of the log. Now, as we use the examples, or as we go through the examples, you get to understand it better. So let's look at a few examples. The first example says log base 10 of 5 cubed is equal to 3 times log base 10 of 5. Again, log base 10 of 11 raised to the power 6 is equal to 6 times log base 10 of 11. Once again, log base 10 of x raised to the power 4 will be equal to 4 times log base 10 of x. Now, these are the 3 basic rules of logarithm that we are learning at this stage. There are other rules, but you will meet them as you go further in your mathematics. We want to use these rules to express the following as a sum of logarithm in their simplest form. So the first one, we have log base 10 of 2xy cubed. Remember, we're going to use the rules we have learned. We are going to express this as the sum of logs. So we have log base 10 of 2xy cubed to be equal to log base 10 of 2 plus log base 10 of x plus log base 10 of y cubed. That is the first rule that we learned. Then we are going to go a step further. So we are going to write this as log base 10 of 2 plus log base 10 of x plus 3 times log base 10 of y. You will see that this time the exponent has come to multiply the log. That was the third rule that we looked at. So now we have written that expression as the sum of logs. Now let's look at the next one. Again, we have log base 10 of y to the power 4 divided by 10z. We are going to write this as either the sum or the difference of logs. The first thing we do is to change the division and the products to become subtraction and addition. And then we change the powers to become multiplication. So let's look at it. So we have log base 10 of y raised to the power 4 divided by 10z to become log base 10 of y raised to the power 4 minus log base 10 of 10z, which was the second rule. Then we go a step further. So we're going to have log base 10 of y raised to the power 4 minus, into brackets, log base 10 of 10 plus log base 10 of z. So you see the multiplication has changed to addition. That was the first rule we learned. And so our expression is now 4 log base 10 of y minus log base 10 of 10 plus log base 10 of z in brackets. Now we are going to go a step further. We are going to remove the brackets. And when we do that, we'll get 4 log base 10 of y minus log base 10 of 10 minus log base 10 of z. That was just removing the brackets. So the negative sign affects the two things in the brackets. Now, there's one more thing we can do. We know that log base 10 of 10 is equal to 1. So we will have to change our middle term to 1. So that will give us 4 log base 10 of y minus 1 minus log base 10 of z. We can rearrange this expression. So we have 4 log base 10 of y minus log base 10 of z minus 1. The third example says log base p of p raised to the power 5 times q divided by r times s raised to the power 2. Again, we will start by changing the multiplication and division to become addition and subtraction. Then we change the powers to become multiplication. And then finally, we write our expression in the simplest and nicest form. So we have log base p of p raised to the power 5 times q minus log base p of r times s squared. That is our second rule. We go a step further by changing the multiplication also to become addition. So we have log base p of p to the 5th power plus log base p of q into brackets minus, in another bracket, log base p of r plus log base p of s squared, also in a second bracket. That is our first rule. Now we change our powers to become multiplication. So we will get 5 times log base p of p plus log base p of q into brackets minus, into a second bracket, log base p of r plus 2 times log base p of s. Now we are going to remove the brackets. And remember, if you have a negative sign in front of the brackets, you will have to multiply everything inside the brackets by the negative. So we have 5 log base p of p plus log base p of q minus log base p of r minus 2 log base p of s. We haven't finished. I'm sure you see why we haven't finished. We can simplify some of those expressions. So we get 5 plus log base p of q minus log base p of r minus 2 log base p of s. Good. Now we want to express the following as a single log, and then we simplify where it's possible. A says 2 log base 10 of 5 minus 3 log base 10 of 3 plus log base 10 of 54. So what do? We are going to first change our multiplications or products to become exponents or powers. So we have 2 log base 10 of 5 minus 3 log base 10 of 3 plus log base 10 of 54 to become log base 10 of 5 squared minus log base 10 of 3 cubed plus log base 10 of 54. That gives us log base 10 of 25 minus log base 10 of 27 plus log base 10 of 54. Now we are going to change our additions to become multiplication and then subtractions to become division. So we are going to get log base 10 of 25 times 54 divided by 27. We can simplify the numbers. I'm sure you can see that certain things can cancel out. When we do that, we are going to get log base 10 of 50. So that expression simply becomes log base 10 of 50. The next example, we have log base 2 of 64 minus log base 5 of 125 minus log base 4 of 256 plus log base 9 of 729. So that gives us log base 2 of 64 minus log base 5 of 125 minus log base 4 of 256 plus log base 9 of 729 to become log base 2 of 2 raised to the power 6 minus log base 5 of 5 raised to the power 3 minus log base 4 of 4 raised to the power 4 plus log base 9 of 9 raised to the power 3. Now simplifying that further, we are getting 6 log base 2 of 2 minus 3 log base 5 of 5 minus 4 log base 4 of 4 plus 3 log base 9 of 9. I'm sure you remember that these can also simplify. So we get 6 times 1 minus 3 times 1 plus 4 plus 3. And our final answer is just 2. Don't you find it interesting that that long expression we had in logs can simplify to just 2? But that is the beauty of log. Let's look at another example. Given that log base 10 of 2 is equal to A, and log base 10 of 3 is equal to B, and log base 10 of 5 is equal to C, express in terms of A, B, C the following. And we have log base 10 of 25 divided by 54. Now to solve this, we will write the numbers in the question as multiples of those given in the question. But first, we have to change from division to subtraction. So we'll have log base 10 of 25 minus log base 10 of 54. That is using the second rule. Then we write this as log base 10 of 25 minus, into brackets, log base 10 of 27 plus log base 10 of 2. we are now using the first rule that we learnt. We are going to change our big numbers to indices with smaller bases. So we'll have log base 10 of 5 raised to the power 2 minus into brackets log base 10 of 3 raised to the power 3 plus log base 10 of 2. Then we go to the next step where our index numbers will come to multiply our logs. So we have 2 log base 10 of 5 minus into brackets 3 log base 10 of 3 plus log base 10 of 2. When we remove the brackets, we are going to get 2 log base 10 of 5 minus 3 log base 10 of 3 minus log base 10 of 2. And finally, we will have 2c minus 3b minus a. I'm sure you can see how we are getting our c and b and a coming into our equation just by substitution. The next example says, given that log base 10 of 2 is equal to 0.3010 and log base 10 of 3 is equal to 0.4771 and log to the base 10 of 7 is 0.8451, evaluate log base 10 of 84. So we're going to write 84 as a multiple of 2 smaller numbers. So we'll have log base 10 of 84 to become log base 10 of 7 times 12. Then we'll break the 12 down further. So we'll have log base 10 of 7 times 2 times 2 times 3. Then we are going to write that expression as log base 10 of 7 times 2 raised to the power 2 times 3. Now we can change our multiplications to become addition. So we have log base 10 of 7 plus log base 10 of 2 raised to the power 2 plus log base 10 of 3. So now we're going to write this as log base 10 of 7 plus 2 times log base 10 of 2 plus log base 10 of 3. Then we can now put the values that the question gave us for log 7 and log 3 and log 2 into our expression. So we are going to have 0.8451 plus 2 times 0.3010 plus 0.4771. We add all these and our answer is 1.9242. Very good. Well, we have come to the end of another lesson. You can do more trials from your notes, and I advise you to do as many as you can. In this lesson, we have learned that the rules of logarithms are: first, log base 10 of x plus log base 10 of y is equal to log base 10 of x times y. Or looking at it the other way, we have log base 10 of x times y to be equal to log base 10 of x plus log base 10 of y. Again, we learned that log base 10 of x minus log base 10 of y is equal to log base 10 of x divided by y. Or log base 10 of x divided by y is equal to log base 10 of x minus log base 10 of y. Again, we saw that log base 10 of x raised to the power n is equal to n times log base 10 of x. Or n times log base 10 of x is equal to log base 10 of x raised to the power n. we can use these rules of logs to evaluate expressions. Well, students, we have come to the end, finally. Make a date so we can continue this topic. In the next lesson, we will learn about logs to base 10 and we'll be using mathematical tables or calculators. See you then. Bye-bye.